Hi, today we are talking about exponent rules and multiplying monomials. Monomials is one term, so we are talking about one term times one term. In this case, the very first rule is in the example number 1. 2 to the third power is really 2 times 2 3 times. And then times 2 to the 7th power is really 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6 times 2, 7 times. So in this case, really altogether, you have 2 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 of them. Okay? Now, if you think about it, this is really the same thing as 2 to the 3 of them plus 7 of them, and that's going to be 2 to the 10th power. So there's a couple ways you can think about it. You can think about it in your head. If you think about 2 to the third power, there's 3 of them, 3 twos, and 2 to the 7th power is 2 7 times. And how many twos do I have altogether? If you can imagine that, that will be easier if you can think about it. When do you multiply or when do you just add when the rule gets more complicated? Okay, so that is the very first rule, and that's probably the only rule we are going to talk about it, but in different forms. So product rule for exponent is if a is a real number and m and n are integers, that means 1, 2, 3, 4, 5, or negative 1, 2, 3, 4, 5, and 0. So the rule is a to the mth power times a to the nth power. So a and a could be anything, but they have to be the same. That's the most important rule. They have to be the same. Then you are adding the m and the n, which is in this case their exponent. So this is a very important rules. Now, also you can pretty much think about this rule by thinking about how many is there. So make sure you write that rule down and make sure you write anything that's read down because there's only two things, the title, the rules, and the formula I just gave you. Let's take a look at example number 2. Example number 2 just tells you to multiply those two. Now I notice the base is the same. So pretty much the base is the same, you add the exponent. So pause your video and try to see can you get the right number. For example, number 2 is 4 to the 17th. Now you say, Miss Wiesman, do I need to multiply it out? In this case, you don't, but some of the smaller numbers you should have. For example, the previous section, we have 4 to the 2nd power, you should tell me that's 16. 4 to the 3rd power is 216. Those are smaller number you should be able to tell me. But 4 to the 17th power is way too big. So we're going to just leave it 4 to the 17th. Example number 3. Now example number 3 is dealing with letters. Now previous problem like right here, you can type it into the calculator and get an answer, but they will give you a huge long answer or maybe in scientific notation. I prefer 4 to the 17th, so sometimes you might not get the same answers like what I want, but you got to be able to recognize it. The next one is just the letters, which is that's what algebra all about. And then in this case, if you look at it, the base is the same, that both base are x, and that's just x. And then if you want me to write down the step, it's really basic. It's just 8 plus 7, so that's going to be x to the 15th, and therefore it's done. So base is the same, both of them's x, it's just adding the exponent, 8 plus 7, and there's your 15. And then so going on to the next one, that's example number 3. Example number 4, you guys try it. Rules apply as long as you have the same base. Example number 4 is t to the 13th power because 4 plus 9, and both of them has t as. Now example number 5 is exactly the same thing, numbers, and there's an x. So in this case, combine the ones that's the same. So it really, when you talk about this whole thing, I want to take it apart so you understand. This is really 5 times x to the 3rd times 4 times x to the 7th. Now if that is the case, you can switch them around because you know 2 times 3 is the same thing as 3 times 2. The number does not change when you have multiplying. I'm going to just say, hey, if I take 5 times 4, then I have x to the third times x to the seventh. We can follow the rules before. So the number just get multiplied together. It's not distribute property. It's just changing the order. There's no distribute property here. So that's just 20 x to the 10th. And that is it. And let's take a look at example number 6. Now you guys try it. Pause the video, try it, and then compare the answer with me. So example number 6, I take the 3 times the 8, number gets multiplied, x to the fourth, and x is 1. So 4 plus 1, that's how you get the 5 right here. And then so because that's a 5, it's 4 plus 1. Make sure you understand that shows up on the quiz. Example number 7, like 6, please try it on your own and then come back and check the answer. All right, number 7, example 7 is negative 3 times negative 5. That's why it's a positive 15. And the same thing for the rest of it. N is just a 5 plus 7. This plus 7. And anything with the M is going to be 4 plus 6. And then therefore you are done. Now I would like you guys to try number 8. The answer for number 8 is 28 to the 10th. It's number 9. And this is in scientific notation form. So in this case, scientific notation form, we're going to treat it like what we done before. And then after you finish with your answer, you got to make sure it gets put back into scientific notation form. So what we have to do here is going to be, we're going to multiply the ones that has not the same base. So that's just going to be 4 times 3. That's going to be 12. Or let me split it up for you guys so you can see. So if you split it up, this is just kind of like 4 times 3 times 10 to the third power times 10 to the 6th power. And when you do that, you understand that if the base is the same, you multiply. If you multiplying and the base is the same, you add the exponent. So 4 times 3 is 12 times 10 to the 9th power. Now the problem is here, it is a 12. And because it's a 12, you know that is not scientific notation. So to write this in scientific notation, you need to know the decimal is right here. And to put it in scientific notation form, you gotta make sure that you understand you have to move the decimal with the 1 digit to the left. 1 digit to the left of the decimal. So I'm moving my decimal 1 place, so that become 1.2 10 to the first power. Because how do you get 12? 12 is 1.2 times 10. That gives you 12. But I still have 10 to the 9th, and this is from here. And I need you guys to understand 12 is from this part. Okay, now again, the base is the same. Now since the base is the same, it's going to be 1.2 10 to the 10th. And that will be your answer. Make sure the answer you have, which is this step, when you multiply together, the 12 needs to be written in scientific notation form. Now when you do the same thing, you are going to add exponent. So even though it's a negative 9, it's still totally okay to add a positive and a negative number together. So first thing what I'm going to do is I'm going to take 2.3 and times 8.5. And that is going to give me 19.55. And you should recognize right away that's 2 decimal place on the left hand side. So that is not a scientific notation form yet. So we need to do something about it. So that's 10 to the negative 4th power, because that's a 5 plus a negative 9. Okay, it's this guy and this guy. So now what I'm going to do is I'm going to change the 19.55 into a scientific notation. So that's going to be from here, the decimal, and moving to there. So that's going to be 1.9 times 10 to the first power. Well, think about it. 1.9 times 10, does that give you 19? Yeah, okay. And then so times 10 to the negative 4. And when you simplify them, because I don't want all kind of 10 bases there, so that's just going to be 1.9 times 10 to the negative 3. And 10 to the negative 3 is coming from those two. And 1.9 is from here. So 19 become 1.9 times 10 to the first power. And now I want you guys to try number 11 yourself. Pause the video right now. I gave you the answer. Example 11 is 4.028 times 10 to the first power. You can definitely check your answer, but I do expect to see work. And if there's no work, you will not get the points for the notes. Example number 12. So it's raising to a power of a power. Now, raising a power to a power is kind of like the same thing that we are talking about before. It's just recognize how many times you're going to write the things. So if you're thinking about the fourth power, remember I told you is the base. So we're going to, like an onion, we're going to peel from outside in. So that's really 2 to the third power one time, 2 to the third power 2 times, 2 to the third power 3 times, and 2 to the third power 4 times. And that's where that 4 comes from. Then under every 2 to the third power, I'm going to say, hey, that's really 2 times 2 times 2. That's from those three. And then you have 2 times 2 times 2. That's from this 3. And then they also have this 3 times 2 times 2 times 2. And then the last one, you have 2 times 2 times 2. So really, if you think about it, the 3 right here is going to be how many altogether? Well, let's count. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, that's really 2 to the 12th power. If you can think about it, it really tells you 4 times. Well, if this guy 4 times, that means 3 times 4. And that is where multiplication comes from. And I want you to think about this kind of problem in your head. You don't have to write it out like I do with writing the 2 12 times, because it's very complicated. But I want you to think about it the way I just wrote out. And special put this part right here. And see, can you imagine it? That's 2 to the 3 times, 3 to the third power, 4 times. So if that is the case, what should you do with your exponent? And if you can imagine that, that will make your life so much easier so you don't get your rules confused. Okay, so now let's take a look at number 12 and 13. Well, 13 is the same thing. Okay, 13 is really saying, all right, if you can imagine this, this is really 5, 8, 6, 4 times. 5 times 8 to the 6th power 4 times. So really, that's 5 to the 4th power and 8 to the 6th power 4 times. So that's 6 times 4 because it's 4 times. So that becomes 24. And since the exponent is small enough, that's going to be 625, 8 to the 24th. And that's your answer. For the next one, I know how much you guys hate fraction, but I want you to think about it. This is a base. to the fifth power, that means everybody in the parentheses gets 5 of them. Okay? So I really have 5 negative sign. That's negative. I also have 2 to the third power, 2 over 3, 5 of them. So that's 2 to the fifth power over 3 to the fifth power. I also have x, 5 of them, y, 2 times, but 5 of them, that's 10. Z, 6, but 5 of them, 30. I hope you can think about it like that. And then because that is the case, that is going to be simplified out. That's just going to be negative 2 times 2 times 2 times 2. 2 times 2 become 4. 4 times 4, 16 times 2 is 32. And then 3 to the fifth power is 81 times 2 is going to be 224, 3. All right? And then x to the fifth, y to the 10th, and z to the 30th. I hope that makes sense to you. If you have any question, please let me know. Please try number 15 and see can you get the answer that I have. So for number 15, the answer is negative 5.37824 m to the fifth power, and n actually to the 30th, because that's n to the sixth power 5 times. So that should be 30th. Okay. And then the very last few, and the last few. Number 16. All right. Number 16, there's a couple more steps now. So there's very hard to do this in your head unless you write some work down. So first thing I'm going to do is I am going to take care the ones that has an exponent right here. The reason for that is because the base for that exponent is only this part. So I want to treat that part first. So I'm going to just write it as 3x squared, like that. But I'm going to take care the second half. But that's 4 to the third power. 4 to the third power. And then x to the fifth power 3 times, so they become 15. All right. Now think about it. This part right here, that's your base. And 3 is your exponent. So that's why you got to make sure your 4 is raised to the third power. Now 4 raised to the third power is going to be 216. And x to the 15th power. So now what I'm going to do is I'm going to combine them by multiplying the 3 and the 216. It's 648, and then it's going to be x to the 17th power. Because again, the base is the same on the x, so 2 plus 15 give you 17. And 3 times 216 is 648. And for that's number 16. For number 17, I know it's fraction, and I know how much you don't like it, but I know you can do it. So this one is going to be just 1 to the second power, 4 to the second power. You can even do that in your head now, I'm hoping. Y to the fifth power, 2 of them. So that's going to be y to the 10th. And then 8, put the multiplication down, 8 to the fourth power, 5 to the fourth power, but then it's y to the third power 4 times. So therefore, y to the 12th. And then I'm going to combine like term. You can pause my video and then just finish it off and come back and check your answer to make sure that you know how to handle this kind of stuff. There are steps in between. I'm not going to show you, so I'll be looking for that. So last thing I want to say is you can write the answers 256 over 625 y to the second power. You can write your answer is going to be 256 y to the 22nd power on top, all on top, over 625. The only thing you cannot write is you cannot have y to the second power on the bottom because that's not correct. Okay, so if y is in the middle, it only belongs to the top. The reason for that is literally it's kind of like y to the 22nd over 1. And because of that, the only thing you can do is stay on top. Okay, so if anything you put it on the bottom, it will be marked wrong. And one more example, number 18. So the problem is going to get complicated like this. And again, we are going to take care of one little parenthesis at a time if they have an exponent. Now, in this case, the only one we have an exponent is going to be the ones at the very, in the middle. So what I'm going to do is I'm going to take care of that part first and work out the problem. So please pause the video and give this problem a try. The answer for number 18 is negative 453.6 m to the 8th, n to the 4th, p to the 12th. And that concludes our notes for today. Thank you so much for watching.